Hi, welcome to another webinar on my series on passing NVIDIA certified examinations. In this particular case, we're going to take a look at passing the NVIDIA Certified Professional Generative AI LLM exam. Just a disclaimer, everything in this presentation is my own personal opinion, doesn't represent the opinion of my employer or anyone else. I've passed a lot of AI certification exams recently from NVIDIA, Oracle, and other vendors. I've got a lot of AI experience. I've created AI applications in Java, Python, and other languages. I've written articles on AI. I've filed patent applications on AI topics, and I've put AI presentations on YouTube. So let's talk specifically about the NVIDIA Certified Professional Generative AI LLMs exam. All right, so the way I would describe this is an AI knowledge exam. It's going to ask you questions that go to your knowledge of the capabilities of different AI APIs and technologies. You don't have to do any programming on this exam, but you do have to know what the programming APIs are capable of doing. There's 70 or so questions. Sometimes the number will be a little bit different, but most of the time it's somewhere around there. It's multiple choice, either select one from four, A, B, C, D, or select two from four or five options. You get 2 hours to answer the exam. You can take it online from your own home. But you will have a live online proctor, and you'll have to show your office at the beginning of the test via webcam, and you'll be monitored by webcam during the exam. You can also often take this exam at an NVIDIA conference because they'll often have the exams on site there if you're at an NVIDIA conference like GTC. So here's an example of what an example question might look like. You'll have like a question statement, you'll have background, a problem, and a goal. So for example, an e-commerce business with a large language model app has poor performance or poor accuracy or results or hallucinations or some other problem. And your goal is to fix the problem. And so what you need to do is you select the best answer from four alternative technology stacks intended to solve the problem. This requires understanding all of the options that are listed in each of those answers, A, B, C, and D, and then be able to select the best combination of the technology intended for that specific problem. Like one solution might solve performance, another solution might solve hallucination. You need to pick the stack that's the best fit to solve the customer's specific problem. I found the professional generative AI LLMs test to be harder than the professional agentic AI and the professional accelerated data science exam. Depending on your background, you may find it easier than those or harder, but that's what I thought it was. Now, so let's get towards studying for it. Well, there's a number of different ways you can approach studying this. There is the NVIDIA certification study guides for each exam, and I'll take a look at that study guide for this exam in just a minute. There's also the NVIDIA website, there's GitHub sites, there's blog posts, YouTube channels. There's all sorts of general AI sources you can look at on AI and machine learning. Articles like Attention is All You Need, and all sorts of third-party study sites, blogs, Udemy, and so on. When I took this exam, all I studied was the NVIDIA Certification Study Guide, but I do have a fair amount of previous experience in AI. And when I studied for one of the earlier course certification exams, I did take a class, a third-party prep class, but not for this exam. All right, so let's take a look at the NVIDIA Certification Study Guide and what it recommends for studying for this exam. So bring it up here. So here's a look at the website where you would go ahead and sign up to take the exam. You click on this little button, register for the exam. Here's a little description about the exam, 2 hours, $200, 60 to 70 questions. Um, the various FAQ and exam policies. Here's a list of the topics. Again, it's about what you expect for Gen AI. The topics include large language model foundations, prompting, prompt engineering, including zero shot, one shot, few shot, adaptation strategies, chain of thought, data preparation, fine tuning, data set curation, tokenization, domain adaptation, customizing LLMs for use cases, optimization, acceleration with GPUs, distributed training, performance tuning, batching, memory optimization, and efficiencies, deployment and monitoring, including building scalable inference pipelines, containers and orchestration, real-time monitoring, reliability, lifecycle management, and then evaluation and responsible AI with benchmarks, error analysis, bias detection, guardrails, compliance, and ethical AI practices. Now, some of these topics were on the associate LLM exam, but this exam is much more sophisticated in its topics. So while I do recommend taking the associate exam before you take this exam, um, don't assume you're going to get the same score when you take this exam that you got on the associate exam. This exam is much harder than the associate exam. All right, so let's take a look. They do recommend some different classes. Some of these are self-paced and cost money. In fact, all of these have a price tag, but sometimes you can get some of these self-paced classes for free. Um, here's the exam blueprint with each of the sections. LLM architecture, prompt engineering, data preparation, model optimization, fine-tuning, evaluation, GPU acceleration, optimization, model deployment, production monitoring, reliability, and then safety, ethics, and compliance. We're going to go through each of these sections in the study guide, so I'm going to skip past this part, and let's go over to the study guide. So you can click this link, or I've already got it up on this tab, so we'll go over to this tab. All right, so let's take a look. This study guide follows the same general format that most of the study guides follow. That is, it's got a cover page. It's going to describe the exam, and then it's going to dive in and show you a little bit about each of the topics. So the first thing they do is they give you kind of a job description of what they think a generative AI professional does and what sort of knowledge they have. So responsibilities like model development and training, evaluation, optimization, deployment and scaling, and innovation and research. And then their recommended qualifications and experience for taking the exam, understanding and familiarity with the various technologies and proficiency, experience, and so on. Now, they mention in here coding skills, but there are no coding questions on the exam, but you do have to have some understanding of the APIs. And one good way to get that understanding of the APIs is to actually do coding with LLMs. So I highly recommend that. All right. So let's talk about each of the topics. So each of the topics follows this basic approach that they describe here. They give you the topic name, the weight of the topic. So this LM architecture has 6% of its exam weight. They give you the various topics that fall underneath LLM architecture. In this case, it's applying foundational LLM structures and mechanisms like encoder decoder, transformer architectures, extracting embeddings from encoders and decoders, implementing advanced sampling techniques, understanding output sampling techniques, and understanding the concept of embeddings. And then they give you a number of links to courses that they map into these topics, as well as some suggested readings that map into the topics. So my number one study tip is to read all of the suggested readings. I found that a lot of the questions on this exam and the NVIDIA certification exams in general come from these suggested readings. So, for example, attention is all you need is a classic paper on AI. So it's really important to the whole transformer encoder decoder approach. So I highly recommend reading Attention is All You Need. But this is also a pretty good one. This NVIDIA blog post on mastering LLM techniques for training. So go through all the suggested readings before you take one of the tests that maps in. All right, so let's go on to the next topic. The next topic is prompt engineering. Again, prompt engineering, they gave it an exam weight of 13%, but I wouldn't, when I took the test, I think I had more than 13% of my questions were related to prompt engineering. So I highly recommend you spend a fair amount of time studying prompt engineering, including things like how to engineer an effective prompt, prompt templates, chain of thought, understanding how you're going to use prompts with small data sets or specialized domains, understanding the differences between zero shot, one shot, few shot techniques, training decoder based LLMs for causal language modeling, designing LLM wrapping modules, built-in validation and constrained decoding for improving consistency, reducing hallucinations, better user experience. And then again, they might recommend a couple of these NVIDIA courses, building LLM applications with prompt engineering and building retrieval augmented generation agents with LLMs. Retrieval augmented generation is going to be in the exam a lot too. I saw that in a lot of the questions. And then some suggested readings, mastering LLM techniques, an easy introduction to LLM reasoning, AI agents, and test time scaling, training a reasoning capable LLM, multi-turn conversational chatbots, and so on. All right, the next section was data preparation. Preparing data for pre-training, fine-tuning, or inference by cleaning, curating, analyzing, and organizing data sets, tokenization, vocabulary management. So understanding how to clean and curate data to handle missing data, normalizing and scaling, and analyzing the class imbalances and feature distributions. And so again, that's more of your data scientist approach, but you do want to have that understanding of what you're doing there. Organizing the data sets, ensuring correct formats, preparing data for modeling, and selecting and training the tokenizers and optimizing tokenization strategies and vocabulary size to fit tasks and resources. And here we've got their suggested courses, a course on transformer-based NLPs, and adding new knowledge to LLMs. And in the suggested readings, we've got readings on the NVIDIA AI Workbench, the NeMo framework, NVIDIA Rapids CUDF, Rapids CUML. So typically what I find when you're dealing with questions that ask questions related to like the workbench or NeMo framework or CUDF or CUML with Rapids, the key is to understand when you would use one over the other. And then when you get a question, it'll typically be something like the example question I mentioned earlier, where they'll present a problem, and then you get to pick which of these is actually the solution for that type of problem. The next topic on the exam was model optimization, using model optimization strategies for LLMs like pruning, quantization, knowledge distillation. There was a number of questions on this topic, and again, all your goal with this topic is generally to improve performance by reducing memory, accelerating inference, making the models compatible with GPU acceleration, and so on. So applying pruning, sparsity, weight activation, quantization to reduce your memory footprint and increase your hardware acceleration. Different approaches to quantization, implementing knowledge distillation to create a smaller, efficient model based on a larger pre-trained one. Conduct systematic hyperparameter tuning, distributed parameter search, batch size adjustments, learning rate schedules. Again, a lot of machine learning here. Using advanced sampling like beam search, temperature scaling, systematic ablation studies to evaluate model and optimization impact, selecting and applying optimization methods like NVIDIA TensorRT, sliding windows, streaming attention, and so on. And training your encoder-based LLM with mass language modeling to understanding the quantization, distillation, and so on. So all those topics are covered in a number of different courses as well as all the readings they listed here. So again, in many of these courses, the same courses you saw on the previous topics, building transformer-based NLP applications, adding new knowledge to LLMs, deploying RAG pipelines, and model parallelism, building and deploying large neural networks. Some of their suggested readings, including like best practices for TensorRT, quantization, and NeMo user guide, DistillBERT, the distilled smaller version of BERT. It's a research article. We've got also some articles from other vendors besides NVIDIA. We've got what is knowledge distillation from IBM. We've got post-training quantization versus quantization aware training from Fiveable, and so on. So there's a number of different articles in quantization and how to save on your performance. All right, so let's talk about fine tuning. Customizing pre-trained LLMs for downstream tasks, You know, using parameter efficient methods, human feedback, contrastive learning, robust evaluation. So how do you align your models with intent via supervised fine tuning or reinforcement learning? A lot of the arguments about, when do you use supervised fine tuning or when do you use reinforcement learning? Uh, Applying contrastive loss for embeddings and using parameter efficient techniques like LoRa, low rank adaptation, and so on. And then we got our recommended courses. Again, same course as before. Some of the readings, though, low rank adaptation is a pretty classic article in this space. A number of NVIDIA technical blogs on parameter efficient fine tuning, um, how to prevent hallucinations, uh, regularization for deep learning, and so on. All right, the evaluation section asks you to assess LLMs versus, with quantitative and qualitative metrics, benchmarking, error analysis, and so on. So, how do you diagnose when the LLM is failing? Using benchmarks, comparing LLM deployments across different platforms, and so on. So we've got the course we talked about earlier about deploying RAG pipelines in production. We've got a number of different blog posts and documentation, like the NVIDIA docs on retrieval augmented generation, evaluating medical retrieval augmented generation, NVIDIA blueprint, AI blueprints on retrieval augmented generation, and so on. And then you got NEMO Evaluator for doing evaluations, various performance analysis tools, deployment best practices on sizing and GPU selections, and so on. Um, the next section is GPU acceleration and optimization. Configuring multi-GPU and distributed training setups, applying tensor core and mixed precision optimizations. Now, again, this is a functional exam. So we're not going to ask questions on exactly how you do this, but it's more like at a high level, how are you doing this? And so we've got like the CUDA best practices guide, uh, best practices for parallelization, batching, and so on, PyTorch, Lightning. Um, all right, model deployment, deploying LLMs in production through containerized pipelines, dynamic batching, configuring and managing the serving using Kubernetes and Ensemble workflows. So really, again, this is, a focus on building RAG pipelines using Kubernetes. Uh, so a lot of the readings are on, NVIDIA NIM microservices for accelerated AI, NVIDIA and NIM for LLMs, uh, with Mistral, model configuration, Dynamo Triton, and scheduling and batching using Dynamo Triton. Production monitoring and reliability, establishing monitoring dashboards, evaluating benchmarks against, your LLMs and so on. So, tracking logs, errors, continuous benchmarks, automated tuning, and so on. So again, the readings for this are things like, improving LLMs, um, you know, causal language modeling, mass language modeling, and so on. And then our final section, like a lot of these exams, is a section on safety, ethics, and compliance. So practicing responsible AI practices throughout the LLM lifecycle, auditing for bias and fairness, implementing guardrails, monitoring for ethical compliance, applying bias detection, and so on. Audit LLMs for bias and fairness, configuring monitoring systems, and using guardrails. So your courses are the same ones we've taken a look at before, on RAG agents and so on, and LLM applications with prompt engineering. So we're looking at from some suggested readings like building an enterprise retrieval augmented generation pipeline, demystifying retrieval augmented generation, observability, and AI, large scale production of retrieval augmented generation, observability tool for Gen AI, NVIDIA AI blueprints, and measuring effective performance of AI guardrails. All right, so that's a brief look. It looks like there's about 40 or 50 readings in here. So it's a decent amount of stuff to read, not counting all the various courses they mentioned. And there's about a half dozen of them they mentioned throughout that. So that is a brief look at the NVIDIA Certified Professional Generative AI LLMs exam. Again, I think this is the hardest of the three developer professional exams between Gen AI, Agentic AI, and Accelerated Data Science. The OpenUSD Professional is a slightly different type of exam. So even though it's considered a developer exam, it's much more hands-on than this exam or the professional data science or the professional agentic AI. The three I mentioned first are all sort of functional exams. Really, do you understand the functionality of the APIs? The OpenUSD exam is really a hands-on developer exam in a lot of ways. Do you really know how to code that's the OpenUSD? So that's why it's kind of different, and I don't really like comparing it to the other professionals because just something that's very different. And depending on what your skill level is, it might be easier or harder than these other professional exams. All right. Well, anyways, thanks for watching this video on the NVIDIA Certified Professional Gen AI LLMs, and tune in next time when I'll cover another one of the exams.